This is lesson 12.4, Permutations and Combinations. Let me get you familiar with a few vocabulary terms before we start computing permutations and combinations. So the first vocabulary term that you need to be familiar with is sample space. The sample space is a list of all people or objects in a group. Secondly, you need to know the probability of an event happening. A probability is the number of favorable events divided by the number of possible events. Let's just work with determining possible outcomes and finding probabilities. Number 1. It says determine the number of possible outcomes. A penny, a nickel, and a dime are tossed. So let's first consider the penny. What are the possible outcomes when you toss a penny? How many outcomes are there? Well, it could be heads or it could be tails. So there are 2 possible outcomes. Then we consider the nickel. When you toss a nickel, well, the same is true. It could be heads or it could be tails. So there are 2 possible outcomes. And we know the same is true for a dime. So 2 times 2 is 4 times 2 is 8. There are 8 possible outcomes when tossing a penny, a nickel, and a dime. Okay, let's look at B. A white or red ball cap comes in small, medium, or large. So we have 2 events here, choosing a color and choosing the size. So how many possible outcomes do we have in choosing color? Well, there's red and there's white. So there's 2 possible outcomes. And then we have 3 sizes. So there are 6 possible outcomes in choosing this ball cap. Letter C. A number cube is rolled 3 times. So the first time that you roll the number cube, you have 6 possible outcomes. The second time is 6, and the third time is also 6. So there are 216 possible outcomes when rolling a number cube 3 times. Letter D. There are 4 choices for each of the 5 multiple choice questions on a math quiz. So there are 5 questions on this quiz, and each question has 4 choices. So for the first question, we have 4 possible outcomes. For the second one, 4. Third one, 4. And for the fourth one, there's also 4. So in total, there are 256 possible outcomes. Try letter E on your own. Pause the video now. Okay, for letter E, a state license plate is issued with 4 letters followed by 2 numbers. So there are 6 characters in total on your license plate. So for the first digit is going to be a letter, the first character, so there are 26 possible outcomes. The second character is also a letter, so there are 26 possible outcomes. The third one is also an alphabetical character, so there's 26, and the fourth one also. Now, how many digits do we have as far as numbers? We have 0 and 1 through 9, so that's 10 for the 5th character and 10 for the 6th character. So when you multiply all of that, you have 45,697,600 possible outcomes. Okay, let's practice finding probability. It says 2 number cubes are rolled. What is the probability that the sum of the numbers on the cubes is 12? What is the probability that the sum of the numbers on the cube is 12? Well, we need to find out what the total number of outcomes is. The total number of outcomes would be 6 for the first number cube times 6 for the second number cube. That would be 36. That's the total number of outcomes. For each of them, it would have to be a 6 plus a 6. So there's 1/6 on the first cube, and there's only 1/6 on the second cube, so it would be 1 out of 36. Okay, all right, let's go on. Number 3. In a lottery game, you pick a 4-digit number. One of these numbers is the winning number. What is the probability of winning? So we have to find out. We know that there's only one favorable event, one winning number, out of how many total numbers. So there's 4 digits. The first digit has 10 possible outcomes, 0 and then 1 through 9. The second one has 10 possible numbers. The third one has 10, and the fourth one has 10. So that would be 1 out of 10,000 is the probability that you would pick the winning number. Okay, let's go on. Very important that you write down this definition. Permutation. A permutation is when the objects of a sample space are arranged so that the order is important. For a permutation, the order is important. Okay? Okay, so let me give you the formula for a permutation. A permutation of n objects taken r at a time equals n factorial divided by n minus r factorial. I know some of this is foreign to you, so let me go through using a number instead of just variables, using numbers to show you how you will calculate permutations. So suppose we want to find the permutation of 10 items taken 6 at a time. Okay, so 10 is n and 6 is r. So here's what you would do. You would say 10 factorial, which means this: 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be 10 factorial. Over 10 minus 6 factorial, which is 4 factorial, which is 4 times 3 times 2 times 1. Notice what happens is that you can cancel these factors, common factors, and so the permutation of 10 items taken 6 at a time, if you multiply 10 times 9 times 8 times 7 times 6 times 5, you would get 151,200. So there are 151,200 ways to arrange 6 items out of 10 so that the order is important. Okay, let's try another example of a permutation. Let's try this one. Permutation of 7 items taken 2 at a time. So, again, following the formula, I need to do n factorial. That would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 2, which is 5 factorial. 5 times 4 times 3 times 2 times 1. Notice again that all the common factors can be canceled, and 7 times 6 is 42. So there are 42 ways to arrange 2 items out of 7. We'll do one more. Let's try this one. Permutation of 9 items taken 4 at a time. So we would do 9 factorial. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 9 minus 4 is 5. 5 factorial would be 5 times 4 times 3 times 2 times 1. So we go ahead and cancel all of our common factors, and let's multiply. We have 9 times 8 times 7 times 6, and it's 3,024 ways. Okay, tomorrow in class we'll work on ways to apply this. Right now all I want to know is that you know how to calculate a permutation. Okay, all right, let's go on. Let's look at a combination. Combination is when objects in a sample space are arranged so that the order is not important. Notice that here, order is not important. Okay, let me go ahead and give you the formula for a combination. If I have combination of n items taken r at a time, you would do n factorial divided by n minus r factorial. Looks just like a combination, like a permutation, except we're also going to multiply by r factorial in the denominator. So let's look at an example. Let's try this one. Let's do combination of 8 items taken 5 at a time. Here we go. So we do n factorial, so that's n times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 8 minus 5 is 3, so 3 times 2 times 1 times r factorial, which means 5 times 4 times 3 times 2 times 1. Okay, so everything that is common, we're going to go ahead and cancel, and we're going to multiply. So we do 8 times 7 times 6 is 336 divided by 3 times 2 times 1, which is 6. And we simplify. 336 divided by 6 is 56. There are 56 ways to choose 5 items out of 8 where the order doesn't matter. Let's try one more. Let's do this one. The combination of 6 items taken 4 at a time. So again, we're going to take our n and we're going to find n factorial. So that would be 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Then we have 6 minus 4 is 2. 2 factorial is 2 times 1 times 4 factorial times 4 times 3 times 2 times 1. Notice that all of that cancels, and we have 30 divided by 2, which is 15. Okay, so for now, really that's all I want to do with you. We're going to do a lot of practice on how to apply permutations and combinations, but for now I have a few problems that I want you to do on your own. So let's go ahead and do permutation of 7, 4, permutation of 2, 7, and then you can do combinations, combination of 7, 3, combination of 12, 8. Okay, we'll work on this some more tomorrow. God bless you. Have a great night.